Okay, I am recording. Let me get my little picture out of the way there. I think you can see me up in the corner. Hi. I decided to try to do a really quick video that kind of goes through a lot of these problems that we've been doing for the last 3 days. I've got people who've gotten stuck on different ones. I've done some one-on-one sessions, and I kind of know what the questions are now. If I was going to do these kind of in a row, I think there's about 10 problems here, and I could do them in 10 minutes. This may turn into like a 20-minute video because I'm explaining things. But most of these problems should take you less than a minute to do once you understand the concept here. And I was noticing the one problem that wasn't on this particular one, I think this is one that I gave you on Wednesday, is that it doesn't have a uniform distribution problem. So if I have a uniform distribution, let's say I'm rolling a dice. Let's say I've got a 20-sided dice. I think they make 20-sided dice. So if it's a fair dice, everything has an equal likelihood of being drawn. And so the distribution looks like this. I've got 1, 2, 3, 4, all the way to 20. So this is some curve here, and it should be flat because everything has an equal likelihood. And this thing is actually 20 long because each bar is 1 wide. So it's 20 long, and the question is how high it is. And the only trick for this is knowing that this thing has to add up to 100% or 1. So I know that, you know, the height times 20 is equal to 1. And so I divide both sides by 20, and so would be 1/20. That's for a uniform density curve, or uniform distribution, because a uniform means that it's exactly the same all the way across. Now we can have ones where they look uniform, but this is truly uniform. For rolling dice or things like a spinner, where everything's equally likely to happen, it's absolutely uniform. It's not, it doesn't kind of look uniform. It is uniform. Okay, so that's probably 2 minutes there already. Let me clear this. Okay, I got a large set of data. I've got this picture over here. It's totally not necessary, but it's kind of nice because I can see, oh, there's my center, my median of 57, and a standard deviation of 3. So I know, like, okay, that's one standard deviation at 60. If I go down a standard deviation, it should be 57. Don't need any of that. This is just to kind of cue up the idea. We're looking for a z-score. Okay, 55.5 is going to land, you know, roughly here. So I know it's going to be a negative z-score because if it was over here, it would end up being positive. And that means I'm going to subtract the mean and the number that I landed on. Now, it's hard. If this one's supposed to come first, if you happen to get them reversed, you will get a positive number, but then you'll just need to remember, oh, it's the right number. I just need to make it negative because I know it's got to be negative because it's on 55.5 is on this side of the mean. So I usually just grab the 2 numbers, subtract them. Sometimes I get them in the wrong order. It's fine. And then once I get that, I'm going to divide it by, I need to, how many standard deviations is this? It's not one full standard deviation. That is one full standard deviation. This is slightly less than that. So I divide it by, you know, my measuring stick. Every unit is 3 long because my standard deviation is 3 long. So when I do that, now, let me show you a trick. That sometimes will work and sometimes won't. 55.5 minus 57 is negative 1.5. Now, if I try to divide here, it's not going to work because it's going to divide the 57 by 3. So I need to do one of 2 things. I need to back up and say negative 1.5 divided by 3, which gives me the answer, 0.5. Or if I knew I was going to do that to start with, I could do 55.5 minus 57 divided by 3. Negative 0.5, which makes sense to me. It's negative. It's not quite a full standard deviation away. So that is how far it is in standard deviations. That's what a z-score is. How many standard deviations am I below? A negative standard deviation. How many standard deviations above? One last thing I'll just show. 57, let's say I grab the numbers and put them in backwards. Okay. And I divide by 3. This is still the right number. It's the 0.5, but it is telling me it's landing on the right side. So I just need to say, oh, wait, okay, calculator did my work for me. I just need to make this a negative 0.5, and I hit submit. And hopefully that's going to check. Huzzah, huzzah. Okay. I've been watching The Great on Hulu, which is why I'm saying that a lot now. Okay, let's clear. Where's my annotations? Clear all drawings. And we'll go to the next one. I'll probably go a little faster now that I've explained that. Okay, this one did not give you the chart. You don't need the chart. If you want to draw the chart, which I probably will do real quick, you can, but you don't need it. All right, so if I was going to draw this, 58 is here, and standard deviation of 3, and 52 is going to land somewhere over here. Okay. Now, just to get it in my head, standard deviation is 3. So at 55, that's 1 standard deviation. So I know my z-score is more than 1, because if it was 55, my z-score would be a -1. Okay. I also know, just to preview, if I go up 3, that would be 61. I know that in between there is 68% of my data. I'll come back to that, but that's an important point that I think people are struggling with. It's not relevant to this problem. All right, so I'm going to do the same thing I did last time. I'm going to that to do 52 minus 58, which tells me, oh, that's -6 down. And I'm going to divide by 3. Oh, that's -2. So it's actually 2 standard deviations away. Okay. These first couple I made it so you could probably do it in your head. The divisions and the subtractions aren't super hard, but you know, calculator does all the work for you. Let me go to the next slide and then I'll clear my down here. I'm in my way here. Okay, let me clear those out. All right, some random sport called insect tennis. Mean is 46, standard deviation is 7. So once again, this is what my curve looks like. Until you're super comfortable doing this, I would always draw the curve. Standard deviation is 7, which means 1 standard deviation down, 39. 1 standard deviation up is, what is that, 53? Oh, 2.5 standard deviations. The other way to say this is my z-score is 2.5. This is the same thing. Let's see, below, so my z-score is actually a -2.5 because of the below, but 2 different ways to say that. I can say I'm 2.5 standard deviations below, or I can say I've got a z-score of -2.5. So it's going to land over here somewhere, pretty far away, definitely below 39, because that's 1 standard deviation. And so I'm just going to figure that out. I'm going to say, well, it's got to be 46. I'm going to subtract 2.5 of these. The other thing I could do, I could just figure out, well, what's 14 down from 46, and then subtract another 3.5, because it's 2 away, which is 14, and then another half is 3.5. Either way it'll work out, but now that I've got my thing done here, I can just use the calculator. Okay, 46 minus 7 minus another 3.5 would give me 28.5, or once again, if I do 46 minus 2.5 of these 7, 28.5, either way. And the main thing that you should definitely notice is I know it was going to land over here somewhere pretty far away, 2.5 standard deviations. Huzzah. Okay, let's see, back to this, annotation, clear. All right, fish bowling, very popular sport. Mean of 32, standard deviation of 6. Once again, 32, standard deviation of 6. So I know I got 1 standard deviation is going to be 38. It's going to be 26, I think. And report is 53. Ooh, that's way up here. That's, you know, that's out here somewhere. Okay. Okay. What is its z-score? I'm going to just guess off the top of my head. At least, it's probably at least 3. Okay. So once again, 32. This is above, right? Oh, we're looking for the z-score. Okay. 32. I'm going to subtract that from 53. That'll give me the positive number I'm expecting. And then I'm going to say, well, how many sets of 6s is that? Okay. And I'm going to let the calculator do the work for me here. Positive number, that's what I want, divided by 6. 3.5 standard, way off the scale. Okay. This is in like the 99.99 percentile. That's out. Okay. Okay, let's clear this. All right, we're using our empirical rule. Okay, in our empirical rule, 68% of the data is between these 2 lines, the red lines. 95% of the data are between my 2 purple lines. And almost all of the data, 99.7% of the data is between the 2 blue lines, which means there is only 0.3% left outside, half of it for this side, 0.15%, which is actually 0.0015 for this side, and also that little tiny sliver right there is 0.155%. So I'm going to use these numbers to help me figure out this question here. Okay, so 141, I've got a nice picture here. There's my mean, standard deviation of 9. Each one of these is kind of 9 apart from each other. Portions that are below 123. Now these problems are set up, if I'm asking to use this, they should land right on the line. Otherwise you could estimate, but your answer would be pretty far off. So 123, where is that? 123 is here, because that number right there, 141, that's going to be 132, and then that's going to be 123. So that's where that lands. 2 standard deviations out. Okay, so I'm curious about how much data is below that number. I'm going to change color first. I want to know what's from this point down. Well, we know that 95% is in this middle section, which means we have 5% to split between these sections on outside of the purple lines. So I got 2.5% on this side and 2.5% on this side outside of this. There's 2 ways to write the answer. One of which is 0.025, that's the percentage. I can type in 2.5%, and Desmos says of what? Because percent is meaningless unless you're comparing to something. So if I say of 1, it'll say, oh, that's 0.025. What you cannot put is 2.5, because in Desmos minds, that is 250%. Okay? So if I submit 2.5, that is incorrect. I need to change it to 2.5% of 1, or just 0.025. The only trick to doing the 0.025 is getting it to move over 2 decimal places instead of 1. It's easy to get the decimal in the wrong place. You have to be precise. Huzzah! Okay, let me go to the next slide. No idea how long this is taking. All right, same question. I also spelled empirical very curiously here. Should be with an I. Once again, 36, there's our middle. Each one of these lines should be 5 away from the middle. So 36, this is 31, 36, this is 41, 46, 51, and that's going to be, let's see, subtract 26, 21. Okay. So those are my numbers. What portion of the value are above 41 in the distribution? So 41 is here. I'm interested in what's out here, and what I know because of the empirical rule is, oh, no, I know that one. Okay, this is just 1 standard deviation away. I know all this data in here, 1 standard deviation is 68%. I landed right on that line there. So I can figure out, oh, well, that means there's 100 minus 68, there's 32%, but it has to get split between the 2 tails. So I got 16% over here, outside of this, and I got 16% over here to the right of the red line here, okay? The other way I could ask this question, if I ask you below, you just know, oh, below is, I got 16% out here, and it's whatever's left over. I guess it's 84. So I could ask you below, but this asks for above. I still have to figure out this section is, and then I work backwards. How did I get that answer? Oh, that answer, I just noticed, why is that answer in there already? I think it's because I did this problem earlier. So sorry if that was confusing. Okay, let's go to the next one. Clear. Historical study, okay, what are we looking for? Let me draw my picture real quick. Very bad normal curve. 47, standard deviation of 4. So 1 standard deviation up would be 51. 1 standard deviation down would be 43. I don't know if that's important, but I'm going to throw it in there. Oh, 41.218. What's its z-score? So that's going to land roughly here. There's my 41.8. It's going to be negative 1 point something is my guess. But once again, with the way we figured out the z-score is we take our result, our number, we minus from the mean, and we divide by, well, how many standard deviations is that? Okay. And once again, if I do 47 minus 41.8, I will get the right number with the wrong sign, because this has got to be negative. So I'm going to put that in there. 41.8 minus 47. Oh, forgot to put parentheses. Okay, I'm just going to remember that's negative 5.2. And negative 5.2 divided by 4. And it's negative 1.3, which is what I was gonna guess negative 1 point something. Huzzah! No huzzah that time. That's disappointing. Okay, fish antelope, antelope fish, very popular fish. It's up there with tilapia. Let's see. Let's clear. Okay, they've got a bunch of weights. They are a giant fish. They weigh 62 kilograms on average, and they have a standard deviation of 6. So 62. Got my curve here. And I know one standard deviation up would be 68, and one standard deviation down would be 56, if I'm doing that subtraction right. Not really important, other than it gives me some sense of where this thing will land. Z-score per data point equals 3. So that's going to be up here. Okay. What's the actual weight? That's a little weird. Wonder what that is. So the way we figure out whatever this number is, this is the z-score. And once again, we know the z-score is the data point minus the mean divided by the standard deviation. That's what the z-score is. So I'm just plugging my numbers in, just writing it out formally there. Let's see. So we got minus 62. We're looking for this number. We're dividing by 3. It's equal to, oops, no, it's 3. We're dividing by 6. Now, there was a way to reason this out, but I just want to show you if this is some weird numbers. It's like, oh, well, I got to get rid of the 6. Multiply both sides by 6. To get rid of this, I'm going to call this x, or d. So I get x minus 62 equals 18. I add 62 to both sides, and it is x equals 8. Okay. The other thing is, because it was 3, you're like, oh, was just 3 times 6 away? Yes, it is. It's 3 times 6 away. It's 80. Okay, so let's do this. Put in the 80, which, oh, that was the answer there. I think I fixed that. It doesn't say the answer there anymore. All right. So this is where I show you how to use this calculator. Clear all my annotations. Okay, this is just showing, hey, this is the normal curve, 0 to 1. If I wanted to do from 10 with a standard deviation of 2, it's not on the graph anymore. I got to use a little thing to see it. That's what it looks like. And then if I wanted to find out how much data was between 8 and 12, see the question up here, 8 and 12, then I could just type in, oh, it's going from 8 up to 12. Oops, up to 12. Hey, look at that, 68% between 8 and 12. One standard deviation down and one standard deviation up. Just showing you this thing works. You can use this for almost anything. How much is above 8? Get rid of that. That turns into a little infinity. There's 84% above 8, which makes sense because there's 16% below that one standard deviation. Okay. If I wanted to see how much was below 14, put 14, get rid of that. 97.7 below, which makes sense because we know these tails for 2 standard deviations are 2.5 each. So there's not exactly 2.5. This is where the 95 is a rough approximation of how much data is in the middle. Okay, almost done. Okay, so this is where you can open up one of these calculators so you can use it. I'm going to actually put it in a different window so I can jump back and forth. And I'm going to go to the next one. Okay, I do crosswords with a standard deviation of 3 in 3 minutes. And I'm going to actually, so I'm going to visualize this on the other. 12 and 3 are the numbers you have to remember. And we're trying to figure out what percent are less than 10. Now, before I even drag my calculator out, I am going to draw this out. I am going to draw this out and say, okay, this is what this looks like. There's 12. Ooh, that one's bad. Let me do it again. That's not much better. I don't know why I'm so slanted. Hold on. Let me try this one more time. I don't know. Let's try it a little bit better. That's a little better. 12. Except this is supposed to be 10. No, it is 12. 12. So one standard deviation up would be 15, and one standard deviation would be down is 9. So 68% of the data between those two. What's the percent of crosswords that I finished in less than 10? So 10 is right here. So without even dragging a calculator out, which this might be good for a multiple choice test, without even dragging a calculator out, I'm like, oh, that's got to be, well, this is 16% from 9 down. This is probably like 20%, maybe, I would guess. I don't know for sure, but that would be my guess. Let's see what it is exactly. So I go to my calculator, which I have open there. That's a mess. Okay, so we said it was 12 and 3. And I don't see my graph, so I hit the little zoom fit. And that had some numbers plugged in already. And I think it was, my minimum was nothing. And my maximum was 10. The other thing I can put in here, a lot of times you'll see people put in like -999, which is very far to the left is what we need that to be. But in this calculator, get rid of that. It'll turn to negative infinity. 25% roughly, 0.252. So if I go back here, 0.252. Hey, that's correct. Okay, do the next one. Oh, same problem. I'm not going to redraw it. 12 and 3, 16 minutes or longer. Oh, go back to my graph. Mr. Taylor made this easy for me. Minimum 16, maximum is as far as I want to make it, so I can get rid of that, or I can say 999, just very far to the right. 0.091, about 9%, which once again makes sense because if we think about our picture, 15 is 1 standard deviation. It's a little farther than 1 standard deviation. We know 1 standard deviation leaves 16% out on the end, so that 0.09 isn't in the right neighborhood. Yay. All right, Mr. Zimmerman. So same question, but notice different mean and standard deviation. So if I was going to draw this out one last time, I'm going to definitely be done. Okay. So Mr. Zimmerman's, let's draw the curve first. Maybe that'll make it better. Okay. He's got 8, much tighter standard deviation. He almost always gets an 8. Okay. 1.25 on each side, so 9.25 up, and what's that? 6.75 going down. 68% of the data is in there. That's probably not drawn wide enough. How much is between 7 and 10? So just as an estimate, before we do any work, 7 is right here, almost 1 standard deviation down. 10 is up here. So this is where I'm really kind of guessing, but since there's 68 in the middle there and it looks like I just shifted over, I'm going to guess in the, in the 60 to 80% is my guess. It's going to be a fairly large number. We'll see. Okay, so let's go check. I'm going to go back to my thing here if I can find it. Our numbers, I'm going to leave that up there. Our numbers were, he had an 8 and 1.25, and we were looking for between, I think it was 7 and 10. I hope that's the numbers. Okay, 0.733. What was the numbers? 7 and 10. 0.733. Let's see if that checks. Yay! Ooh, I was nervous there. I was like, this is going to be bad. I went all this way and then screwed up the last one. Okay, the last one is to work in reverse, which I can use this tool, which I will use to estimate what 1/3 or below is, area-wise. But I'm going to show you how to do it exactly. So first of all, let's just think about what the number should be. Change colors again. Purple. So 1/3 of his scores are probably, let's just say, here down. That's a rough estimate. Okay, 1/3 of the maybe a little closer here. 1/3 of the area is from here down. Okay. Now, 0.33. Let me think if I've got anything. Well, I know that 1 standard deviation is 16% to the right, and I know that the average is going to be 50% to the right. So it's going to be somewhere between. It's further over here. It's somewhere between 6.75 and 8. Okay. So I'm just going to guess. I actually don't know the answer to this. Well, I did, but I forgot. I'm just going to guess 7.2. Just made that up. So there's 2 ways I can do this. I can kind of guess at it by using this calculator that I have open here. I can start fiddling with this. Let me close that. Over here, I'm going to say Okay, I said about 7.2 was a guess. It's very hard to see under there. 7.2 gives me 26. That's too low. 7.5 gives me 34. Oh, I'm very close. 7.4, 31, 7.45. Okay, 7.45. I know it's hard for you to see that. It says 0.329 under there. That was me just playing around. Okay. Now, if I don't want to play around, if I just want to figure it out, there are inverse normal distribution calculators where you can just plug things in. And all you've got to do is tell it the mean, which we said his mean was 10, his standard deviation was 1.25, and we want the bottom third of his area. And it says, ooh, I did something wrong. Oh, that's because his mean is, I was like, why? It's wrong. My mean was wrong. And the other thing is I want below 7.46. And I think I've got this thing so it will work with, oh, I gotta go back here. The 7.45, I think we'll check, even though it wasn't the exact answer. Yeah, if you get something close, we'll generally check it for you. That's the way I've got this set up. Okay, that is plenty. Stop share and goodbye.